Today, we're diving into some fascinating research coming out of Cornell University that pulls back the curtain on a major flaw in how we thought AI chats were protected. It's called Whisper Leak, and it's a wild story about how even perfectly encrypted conversations can give away our secrets. So, picture this: you're talking to a large language model. Maybe you're asking for some sensitive legal advice or something personal about your health. You see that little icon in the browser. You know it's using strong TLS encryption, so everything you're typing is totally private. It has to be, right? Well, not exactly. And the reason why is this whole breakdown is about. This brings us to the central paradox of this whole thing. How can something be completely encrypted but still totally exposed? Okay, think of your conversation with an AI like you're talking in a completely soundproof room. That's a TLS encryption. It's a soundproofing. Nobody outside the room should be able to hear the actual words you're saying. The content is locked down tight. Now, imagine someone, an adversary, standing right outside the soundproof room. This could be anyone from your internet provider to just some person on the same Wi Fi. They can't bust through the doors. The encryption is way too strong for that. They can't hear your words. But here's the mind bending part: even without hearing a single word, they can get a really good idea of the topic of your conversation. And that is the whole secret behind the side channel attack called Whisper Leak. So you're probably wondering, how is that possible? Well, the attacker isn't listening to the words, they are listening to the rhythm. They're following this trail of digital breadcrumbs that we call metadata. The whole vulnerability hinges on a feature called token streaming. You know, when you use a chatbot, the answer appears word by word? That's token streaming. They do it to make the AI feel super responsive and interactive so you're not just staring at a blank screen. But that constant flow of tiny data packets creates a unique, observable pattern. And this right here is the heart of the matter. TLS encryption is amazing at hiding the content, but what of your conversation if it still doesn't hide the metadata? An attacker can still see the size of every tiny data packet being sent back and forth, and they can see the exact timing between them. They can't hear the song, but they can hear the beat. They know the rhythm of the conversation. Okay, so we've established that there's a rhythm. Now let's get into how an attacker actually turns that rhythm into real intelligence. How do they listen to these whispers? It's really a three-step playbook. First, the attacker just passively watches the encrypted traffic flowing by. Easy to do. Second, they extract that metadata we talked about, the packet sizes and their timing. Third, and this is the really clever part, they feed all that data into a machine learning model. This machine learning model is basically trained to be a pattern recognition expert. It learns that, for example, a complex legal question about money laundering generates longer, more complex sentences, and that creates a totally different pattern of data packets than, for example, a question about coding problem. The model learns to spot these unique digital signatures and connects the rhythm of the data to the topic of the chat. Now, you might be thinking this is just some theoretical flaw that affects one or two models. No. Cornell researchers tested this across the entire industry, and the results? They're pretty jaw dropping. Let's get down to it. Just how effective is this attack in the real world? Can someone actually pull this off reliably? The answer is yes. In fact, it's shockingly effective. For 17 of the 28 popular LLM models they tested, this attack was able to pinpoint sensitive conversation with 100% precision. That means every single time the model raised a red flag, it was correct. And look at this list. We're not talking about some small obscure models. These are the heavy hitters from Microsoft, OpenAI, XAI, Mistral. Now, that term 100% precision is critical. It means there were zero false alarms. Even when a sensitive chat was just 1 in 1,000 normal conversations, every single time the classifier said, hey, this one's sensitive, it was right every single time. And here's the kicker: the threat actually grows over time. This is figure 4 straight from the research paper. It shows that the more traffic an attacker can scoop up and train the model, the more accurate the attack becomes. A persistent attacker gets better and better at spying on you the longer they listen. So the vulnerability is real. It's widespread and it gets stronger over time. That's the bad news. Now, the good news: the race to defend against these attacks is already on. The researchers looked at three main ways to fight back. First, you've got random padding. That's basically adding junk data to each message to disguise its true size. Second is token batching, where you group a few words together before sending, which totally messes that one by one rhythm. And third, you can do packet injection, which just means sending a bunch of fake noise packets to confuse the attacker. And companies are actually listening and responding. Because of this research, big providers like OpenAI and Microsoft have already started rolling out fixes. What you're looking at here is actual code where they've added random obfuscation field. That's random padding in action. But is this a perfect fix? A silver bullet? Well, not really. This chart shows you the attack's effectiveness before and after defense line token batching is used. You can see the defense helps a lot. It makes the attack much less successful, but it doesn't bring the risk down to zero. A really determined attacker could still have a chance. This is a really great example of responsible disclosure. By the way, the researchers didn't just publish this and set the world on fire. They probably told all the companies back in June, giving them months to work on fixes. And as you can imagine, by default, many of the biggest names had already deployed countermeasures. So this all leaves us with a really big question for the future of AI. For decades, we have poured all our energy into protecting the content of our conversations online. But WhisperLeak proves that's not enough anymore. We also have to figure out how to protect the very shape and rhythm of our conversations. Because as it turns out, even when our data is encrypted, it can still whisper our secrets.